Section 4.1 PDF for a discrete random variable. So with this example, we're going to look at back to the two dice being rolled. Again, with that one, as we discussed, for the sample space listed here. So this table is a display of the sample space. Again, that's kind of like the concept of population. That's a set of all outcomes. So when looking at dice, we have basically two dice here being rolled. So we have 6 ways to roll the first die, and then 6 ways to roll it again. If you go ahead and multiply that together by the fundamental counting principle, that 6 times 6 will give us 36 outcomes. And here that's displayed, all 36 outcomes there for our convenience. What we're going to do is take that and answer the question down here at the bottom. Let X be the number of dots that are face up. For example, if you're looking at the 1, 1 here, there would be a total of 2 dots facing up. So in other words, they're looking at the sum, and these all occur. We're going to look at this as on a diagonal here. Like this one here is like 1, 2, and the 2, 1. So with each one of these outcomes individually, 2 plus 1 is 3. 1 plus 2 is 3. So that the total number of dots face up in this case would be 3, but there's 2 outcomes that do that. So we're going to have to take a note of when that occurs, and then follow that with a probability here. That even for the first one, there's only 1 outcome where the total number of dots is a 2. So that probability would turn into 1 out of 36. We just discussed the one for 3, that there's only 2 outcomes that where the total number of dots face up out of rolling of 2 dice would be a 3. And that's 2 out of 36, and we can simplify that to 1/18. Next, let's go look in the 4s, and again with the pattern with this, you'll recognize that this is all on the diagonal here. So here's this one here for 4. There are 3 outcomes that occurs, where we have 1, 3, 2, 2, and 3, 1. Again, we're not assuming that order doesn't matter, but order does matter, as the first toss then the second toss. So that would be 3. 3 out of 36. And that reduces to 1/12. Yeah. Next one, 4, 5. It's going to kind of, you'll see a sequence here, arithmetic sequence, in fact. Here's our 5s here. We have 4, 1, 3, 2, 2, 3, and then 1, 4, again, when order does matter. There are 4 outcomes that take place to give us the total number of dots is a 5. Therefore, the probability would be 4 out of 36. And then dividing those both by 4, you get 1/9. Okay, next one with the 6. There's going to be one more, so there should be 5 outcomes here. So here's our 6s. And as displayed here, we have 5, 1, 4, 2, 3, 3, 2, 4, and then 1, 5. That makes a total of 1, 2, 3, 4, 5 outcomes. So the probability of getting a 6 would be 5 out of 36. And that can't be simplified. The next one for 7 is actually our greatest probability, would be 6 out of 36 on that big diagonal. And then that would be 1 out of 6 for that probability. I'll show you here that it is the most probable, just kind of following that diagonal, and that's our 7 diagonal there. Making that reduce a little bit more, let's go look at 8. That outcomes for 8 are on this diagonal. We have 6, 2, 5, 3, 4, 4, 3, 5, and 2, 6. That would make a total of 1, 2, 3, 4, 5 outcomes. So therefore the probability would be 5/8. Sorry, 5 over 36. My bad. And as we kind of go through, we have the 4, 3, 2, and then down to the 1 for the 12. And you can see that they start to reduce in the number. So that'll be 1/9, and then 3 out of 36, back to the 1/12. 2 out of 36 is 1 over 18. And then 1 out of 36 is the last one. So that's building up here for going through these next few sequences. Like this would be 3 plus 6 there. That's the 9 diagonal. Then we have, followed by that is the 10 diagonal, and 11, and then 12. The very last thing that we need to do is verify that we do have a PDF. So if I do add up all these probabilities together, we should get 36 out of 36. And we need to verify that just to make sure that we didn't overlook anything. So let me go and grab a calculator and do that. Let's take 1 plus 136 plus 2, 36. Adding those all up. 3 plus 4 plus 5 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. And there you go. You get 36 for the total of the numerators. And of course that would give us 36 over 36, which of course is equal to 1. And that's what you want there. And also to verify that none of the probabilities are negative, nor are they above the value of 1. So there's our PDF from the given sample space here in this example. This will do it here for this section 4.1 on creating and finding PDFs for a discrete random variable.